Okay, so we proceed with question 3. Question 8, 3. Okay, so how to calculate the median. So how do you calculate the median? So the median, it has the formula. You have the median is equals to the lower boundary of the median class plus you have the summation of the frequency over 2 minus we have less than the cumulative frequency over the cumulative frequency of the median class. Sorry, not the cumulative frequency, but the frequency of the median class multiplied by the class. Okay, so you have this formula. What are we supposed to do? They say that what is the median class? So the median class is the class with the smallest cumulative frequency greater than or equal to 1/2 of the total frequency. So what they mean is 1/2 of the total frequency. The total frequency here, when we come to this part, the total frequency here, it is 200. So 1/2 of 200, that's 100. So 100, it is the one which tells us where the median is. So since 100 is our total frequency here, so you have your frequency, summation of the frequency over 2, which is equals to 200 over 2. 2 into 200, that's 100. You have 100 here as your answer. So according to the definition of the median class, it says that it is the class with the smallest cumulative frequency. The smallest cumulative frequency which is greater than or equal to 1/2 of the total frequency. So greater than or equal to 1/2 of the total frequency, which is 100. So the one which is greater than or equal to 100, meaning starting from 100 going up. So the one which is greater than or equal to 1/2 of this, the one which is greater than or equal to 100, that's where the median class falls. So if it's 10, if you find something like 101, that's where the cumulative frequency is. If it's 102, that's where the cumulative frequency. But if according to the data that you have here, you follow the cumulative frequency here, this part. Let's focus on the cumulative frequency. You follow the cumulative frequency here. It says that 1/2 of the cumulative frequency greater than or equal to 1/2 of the cumulative frequency. So like the way it is, this 87, it cannot fall into 87. Why? It's because 87, it is less than 100, but it says that greater than or equal to. So if it is greater than or equal to, meaning 152 here qualifies. Why? It's because 152 is greater than or equal to 100. But 200 here, it doesn't qualify. Why? It's because, yeah, quite alright, 200, it is greater than 100 and equal to 100. But according to the definition, it says it is the class with the smallest cumulative frequency. This class here with the smallest cumulative frequency, which is greater than or equal to 100. So the one with the smallest frequency here greater than or equal to 100, it is 152, not 200. Why? It's because 152 is less than 200 and 152 is greater than or equal to 100. Hope now it's clear. 152, it is the smallest cumulative frequency here. Why? It is because 152 is greater than or equal to 100. Quite alright, 200, it is greater than or equal to 100, but it is not the smallest. It is not the smallest cumulative frequency we have in this data. The smallest cumulative frequency that we have, which is greater than or equal to 100, it is 152. So our median class falls in this row here. That's where our median class falls in this row. So our median class, it is from 45 to 60. That's where our median class is. So even as substituting, we are supposed just to consider these values here in this row. So when we come to this part here, we proceed. So it will be our median class is equals to what is the lower boundary of the median class. Like what I said when we were dealing with the mod, you are not supposed to subtract the 0.5 from the 45. The reason being simple. So since here it is 45, and when you follow how the pattern has been going, we only subtract 0.5. If it was 45, then in the next here you have 46 maybe to 60. That's when you can subtract, because when you look at the difference here, if it is 45 here, then you have 46. The difference here, it is 1. When you divide what is 2 into 1, that's 0.5. No wonder we do subtract to that lower boundary. That's 0.5. But if it is the way it is here, 45, it's just solid. There is nothing like a remainder here. So you cannot subtract that 0.5, because 45 minus 45, that's 0. And 2 into 0, that's 0. So you cannot subtract anything. You just leave it the way it is. So meaning 45 just becomes the lower boundary. You just get it the way it is, as in 45 being your lower boundary under the median class. So here, on the lower boundary for the median class, you have your 45. You write your 45 here, plus. Then the summation of the frequency, it is 200. You divide it by 2. Minus. Then now here, this one, it is less than the cumulative frequency. So since we have this pattern here as less than the cumulative frequency, what are we supposed to write here? It is that cumulative frequency of the lower class next to the median class. So when you come to the cumulative frequency, this part here where there is less than the cumulative frequency, this, it means that the cumulative frequency of the lower class next to the median class. What is our median class here? The median class falls in this row here where there is which is having the cumulative frequency of what? Of 152. Now, since we are having the cumulative frequency here of 152, the cumulative frequency of the lower class next to the median class, it is 87, not 200. Why? It's because 200 it is not the lower class, which is next to the median class. 200, it is the higher class, which is next to the median class. But 87, it is the lower class next to the median class, which is 152. So here, on less than, less than the cumulative frequency, you are supposed to put 87, because 87, it is the lower class next to the median class according to the data that we have here. 87, it is the lower class next to this median class. Okay, so we proceed to the next level, to the next part. So we have this. Okay, now when you come down here, the frequency of the median class, you come here. What is our frequency of the median class in this row? So you have this row here. You have this. What is our frequency of the median class? This row here. What is our frequency? It is 65. You get your 65. You come here and you place your 65. Okay, so it will be 65. Then you multiply by, what is our class interval? It is 15. Okay, we have this. We continue. So it will be 45 plus, what is 2 into 200? That's 100. Minus 87 over 65. You multiply by 15. Where I'm getting the 15, it is this part here. For you to find the class, 15 minus 30 minus 15, that's 15. 45 minus 30, that's 15. 60 minus 45, that's 15. So you can just subtract any of the two. You get the answer, as in your class this side. Okay, so we continue. So you have your 45 here plus, what is you have your 45. What is 100 minus 87? That's 13. You have your 13 here. Then you divide it by 65. Then you multiply by 15. So I will just punch the answer direct. What is 13? You divide it by 65. You're going to have 0.2. You multiply by 15. You're going to have 3. So it will be 45 plus 3 equals to 48. So this one becomes your median class. 48 becomes your median class. You're done. So that's how we solve the median class under grouped data. We continue to the next question for us to deal with standard deviation. So standard deviation, we come to this part here. That's the last question in this paper. So how do you solve the standard deviation when it comes to the grouped data? So the same procedure, you have the formula here. You have your SD is equals to the root of the summation of fx squared minus the summation of fx squared over n over n. This is the formula that we are going to use. I've given you all the formulas that you are supposed to be using when it comes to statistics. All the formulas actually has been tackled. So when it comes to solving, now it's just for you to be serious with all the calculations, because I think statistics, all the parts have been covered. So it's up to you now to just put the same calculations into practice, so that at least you should be knowing what you are doing. So next step, SD is equals to the root of the summation of fx squared. No wonder I was like, we are supposed to do what? To come up with a table which looks like this, because the summation of fx squared here, we have our value here for 4594.50. 4594.50. Just right here, 4594.50. 4594.50 minus the summation of fx. Yeah, just come here. Oh, the summation of fx, come here. Fx 87.15. You include it here. 87.15. 87.15 squared over our n. What is our n? Our n. What is our n? The one which is representing our n here in this case, it is the frequency. That's 200. Okay. Our n, we have your 200 here over 200. So this one, it is not the sample. It is what? It is the population. The formula that we do use when it comes to the sample, when you are dealing with grouped data, this is the formula. Let me show you the formula for the sample. So it will be your SD here, standard deviation, is equals to the root of the summation of the fx squared minus the summation of the fx squared over n minus 1. So this is the formula that we do use when it comes to grouped data, but you're not dealing with the sample. But you're not dealing with the population, but the sample. What I mean by not dealing with the population, if you find that your n, or let me say your f, is not greater than or equal to 30. If your n is less than or equal to 30, we do use this formula, meaning it becomes a sample. But if it is greater than or equal to 30, that becomes a population, and we use this formula. Hope I'm clear. Okay, so we proceed. So SD is equals to the square root of this. So here it's just direct. What is 87.15? When you square it, you're going to have those figures that you're going to calculate. Okay, let's do it together. We have this 87 by that 87.15 squared. We have these figures. Since we have these figures, what next? We divide it by what? We divide it by a 200. We are going to have 30 something. We are going to have 379. So we have our 4. We have our 4594.50 here minus 379,756.125 over 200. Okay. So when you subtract this, you're going to have something like, what is 4594.50 minus 37,9,756.125. Okay, you're going to have something like 79,69 3.875. So you are going to have something like this one, 79,69 3.875. You divide it by 200. So when you divide this by 200, you're going to have 398.4, let me say 7. Then the root of that, you're going to have 19. You're going to have 19.962. This one becomes your standard deviation. You're done with the calculations and you get your 20 marks on statistics. So that's how people do pass. Thank you for following. The next paper we're going to look at is electronics. So I'll be sending starting next week, Monday, Tuesday. I'll be sending some tutorial videos for electronics. Thank you for watching, and thank you for following. Keep on subscribing, keep on liking the videos and commenting, so that at least you should be motivating me, because once you like, you subscribe, and you comment, meaning you motivate me to keep on making more videos. Thank you, and God bless you.